In this control system, I have 4 fans that blow on a wheel to get it to a location determined by the user. That indicates the location. So I marked one of the spokes on the wheel with a marker. The fans are speed control, which is first order. In the center of the wheel is a potentiometer. It senses the angular position of the platform, which is second order. So that's 3 orders. The signal from the potentiometer is put through an RC circuit in order to make the sensor a slow sensor and add another order to the system. Thus, the system is 4th order. Here, I have a potentiometer that's controlled by the user. The signal goes through an ADC converter and outputs a value between 0 and 255 on the LCD screen. Once the value is chosen, the software calculates the proportional and derivative control signal required to output to the fans. PWM signals are sent to the fans accordingly. 3 fans are required to move the wheel counterclockwise, but only 1 to move it clockwise. This is due to the inherent physical resistance of the wheel bearing, which is higher in one direction than the other. Alright, let's run this system. I'm going to adjust the potentiometer to a value. Now let's look at the screen. You see the fans going off. That means something's happening. Alright, I do have a delay in the system, so it takes a few seconds for it to read on the LCD screen, but there we go. We want our system to go to 87. So 87 is towards the top, and it takes a while for the fans to start up too, but then they slowly start moving. It is a slow and sloppy system, unfortunately, but it does eventually get to the point I want it to get to. It does have some sections that go faster and slower, but it adjusts itself accordingly. So you can see that fan just turned on because of the overshoot. And there we go. So it'll hang out around the 87 value that we input. So that's it. That's the system. There you go, Chris, my final project. Thanks.